So here heat transfer by the conduction through the composite material or a composite wall. So if you used different kind of materials, how the heat conduction will takes place. Just I will consider two blocks, two blocks of having thickness x1 and having a thickness x2. So it is one first material and this is second material. Just I will derive here. I will use these two materials. So this is first material, this is second. Consider this is steel material and this is copper material. So here it is having a thickness x1, it is having different thickness, it is having x2. So temperature, I will put a flame here. Imagine that I will put a flame here. So the heat, it will transfer like this and it will pass us here. So it is a T1 and add this joining. I will join this steel and copper material and this area, at this area it is, I will consider as a T2 and this area it is, I will consider as T3. So here which one is the highest temperature? T1 is always higher temperature and T3 is the less temperature, isn't it? So here I will consider, just we need to write these all things. X1 is the thickness of first material, K1. So here this is K1, thermal conductivity of first material and thermal conductivity of second material. K1 is the thermal conductive first material, K2 is the thermal conductive second material, X1 is the thickness of first material and X2 is the thickness of second material. T1 and T3 is the temperature of two outer surfaces. This is outer surface, this is also outer surface, this is inner surface, joining surface. So T2 is the temperature joining point. A is the surface area of a wall. A is the surface area of the wall. This is surface area. A is nothing but surface area. So here just assume that T1 is a higher temperature. Why we need to assume? Because we have to put a plane here, so that's why obviously it is having a high temperature and it is having a less temperature. Now I will apply the Fourier law of conduction. Heat flowing through section 1. I will just, you need to forget this one. Imagine that this is only one material is here. So apply the Fourier law of conduction. What is Fourier law of conduction? Q1 for this first material, Q1 is equals to K1 into A into T1 minus T2. T1 minus T2. I will apply the Fourier law of conduction for only first material divided by X. X1 because this is thickness of the first material. I will consider as equation number 1. Now this is next thing is, I will rewrite this equation. So I will put in terms of T1 in temperature difference, T1 minus T2. So T1 minus T2 is equals to cross multiplication, Q1 divided by K1 into A into X1. So this is equation number 2. So I will keep in terms of T1 minus T2. Next thing is, for similarly for section 2, I will write the Fourier law of conduction. Q2 is equals to K2 into A into T2 minus T3. T2 minus T3 divided by X2. Why this is X2? So this is for second material. So I will rewrite this equation. T2 minus T3 is equals to Q2 divided by cross multiplication, K2 into A into X2. So this is equation number 3. So now this is T2 minus T3 and this is T1 minus T2. Just I will add these 3, 2 and 3. Adding 2 and 3. What will happen? T1 minus T2 plus T2 minus T3 is equals to just I am adding Q1 divided by K1 into A into X1 plus I am adding K2 into A into X2. So just see here, minus 2 T2 plus T2 will get cancelled. So which one is remaining? T1 minus T3 is equals to, which one is common here? Can you take any common thing here? So Q2, Q1, the same temperature which is passing from the same heat is the which is passing from this first block and this second block. So we will consider a Q only, not Q1 and Q2. So I will consider only the same heat, because the heat will not change, the only material will change, but we will consider same heat. So Q also the same. So this will Q divided by A, this is a common thing, and remaining thing is X1 divided by K1 plus X2 divided by K2, Q divided by A. Next thing is here, next part of the derivation is just I will rewrite as this equation. Q is equals to A into T1 minus T3 divided by X1 divided by K1 plus X2 divided by K2. Why this? Because we are finding out the temperature, or we are finding out the heat which is flowing from this area to this area. The same heat is which is flowing, but through the different material. This is called as a composite material. So how much amount of heat is transferring from first to third? This is Q is equals to A into T1 minus T3 divided by X1 divided by K1 plus X2 divided by K2. So this is the expression for a composite material. Suppose if you consider now we have considered, or we have derived the expression for only two materials. We have considered three material. Suppose see here, just I will consider steel, copper and gold. Then what is the expression will becomes? Q is equals to, just I will modify this one, A into, we have considered T1 minus T3. So this is T1 minus T3. T1, this is in between, T2 is there and this is T3 is there. At the end of these wall, T1 and T3 is there. So I will add another one. Means this is T1, this is T2, this is T3 and this is T4. So first minus last, A into first minus last divided by, this is X1, X2, X3, this is K1, K2, K3, means X1 divided by K1 plus X2 divided by K2 plus X3 divided by K3. Is it right? Suppose if I want to add another thing, this is T4 and this is T5, this is X4, this is K4. So next the expression becomes A into T1 minus first minus last T5 divided by X1 divided by K1 plus X2 divided by K2, X3 divided by K3 plus X4 divided by K4. So if you want to add number of the blocks or number of material, then you need to change this expression. So the main expression is Q equals to A into T1 minus T3 divided by X1 divided by K1 plus X2 divided by K2. So this is the composite material derivation, the heat which is transferred through the composite material. So in next video I will solve some simple problems which will ask in your exam.